So welcome to absolute value equations and inequalities. Hopefully we already saw the little quick intro to absolute value, so we're going to jump right into this lesson. There's 8 boxes for this. Let's do number 1 together here. It says solving an absolute value equation. What are the solutions of the absolute value of x plus 2 is equal to 9? Let's graph and check. Well, we would solve this just like we normally would solve an equation. We're going to isolate the absolute value, so I'm going to subtract 2 from both sides here. And I'll get the absolute value of x is now equal to, well, 9 minus 2 is worth 7. So that tells me that x could either be 7 or x could be negative 7. So to graph and check on the number line, here's what we would have. Here would be 0, here would be 7, here would be negative 7. So it would either be this point here or that point here. Remember, we're looking for the distance away from 0 on the number line for these simple type of absolute value equations. Box number 2 is another example. It's a little bit more complicated, so let's try and solve this one the same way. First, we want to isolate everything inside the absolute value bars. So to do that, we're going to add 1 to both sides. Add 1, solve and solve. So we get 4 times the absolute value of 2x minus 3 would now be worth 11, and 1 is worth 12. Next, I would then divide both sides by 4. Divide both sides by 4 to isolate my absolute value bars. So I'm going to move over here. I will get the absolute value of 2x minus 3 is now equal to 12 divided by 4, of course, is worth 3. At this point, I can now solve for the absolute value by setting up 2 simultaneous equations. Because the absolute value of whatever's inside the bars could be positive or negative 3, we set up 2 equations. We set up 2x minus 3 is equal to 3, or we set up 2x minus 3 is equal to the negative of 3, because absolute value could be 2 different locations. And then we solve each one independently. So I would add 3 over here, I would add 3 over here, so I would get 2x is now equal to 3, and 3 of course is 6, divide by 2, and I would get, of course, that x, let me shrink this down a little bit, x would be equal to 3. That's one of the solutions. Or simultaneously add 3 to both sides, add 3 to both sides. I would get now that 2x is equal to negative 3 plus 3, of course, is 0. Divide both sides by 2, and I would get that x is now equal to 0. So how do we check to make sure that this is right? Well, we go back and we plug in. So what if I do 4 times the absolute value of 2 times 3 per se, and then minus 3, and then subtract 1, and hope that that equals 11. Well, let's check it out. This will be 4 times the absolute value of, well, 2 times 3 is worth 6, and 6 minus 3 is just worth 3, and then subtract 1. Does that give me 11? Sure, because the absolute value of 3 is the number 3, and then 4 times 3, of course, is 12. 12 minus 1 is definitely 11. Yep, 11 is worth 11. That seems to work out really nice. Likewise, for 0, if I plug in, I'll get the exact same thing. So, when setting up absolute value equations, we have to isolate the absolute value and set up 2 equations simultaneously, one positive and one negative, after we set up the absolute value. Box number 3 is a U-try. Go ahead and try and solve this absolute value equation similarly like we did in box 2. Hopefully you got it right. If not, here's how you should do it. First, divide both sides by 3. So that would give me the absolute value of x minus 3 is worth 9 divided by 3, of course, is 3. So if we remember from last time, we're saying all numbers 3 units away from 3. That's what this means, right? So we would set it up as, well, x minus 3 could be positive 3, or x minus 3 could be negative 3. In either case, we would solve independently. So x is either going to be, if I add 3 to both sides, worth 6, or x is going to be, if I add 3 to both sides, worth 0. So these are the 2 solutions. So 6 and 0 are the 2 numbers that are 3 units away from the number 3. In box number 4, we talk about how sometimes an absolute value equation doesn't have a solution. Okay? Now remember, as a side note, we could never have the absolute value of something equal to negative whatever. I'll put a star over here. Okay? This doesn't make any sense. Okay? The reason is because absolute value is considered a distance from certain point on the number line. So we can never have it be equal to a negative. So keep this in the back of your mind as we do this particular problem. So first, I want to do the same thing as I normally would. I'm going to isolate the absolute value. So I would subtract 12 from both sides. So I get 3 times the absolute value of 2x minus 9 is now worth 10 minus 12 is negative 2. I can already tell this is not going to have a solution because it's equal to negative, but I'm not yet done isolating my absolute value term. I'm not yet done isolating this term. So I'm going to go ahead and keep going just to pretend like I don't know what's going on. So if I divide both sides by 3, divide both sides by 3, I get the absolute value of 2x minus 9 is worth negative 2/3. So look, this has the exact same structure as that, in the sense that I have the absolute value of something is equal to a negative number. Whenever this happens, there is no solution to the original absolute value equation. Sometimes that happens and sometimes it's okay. Box number 5 is probably the most important box of the lesson and probably the spot where most students get confused. So we're going to solve an absolute value inequality. Remember, an inequality is different than an equation because it has an inequality sign. There are two types of inequalities that we need to be able to solve concerning absolute value. The first type over here on the left is solving a less than inequality. This is the less than symbol. Like number 2 would be solving a greater than inequality. Whenever you have a less than inequality, you're guaranteed to get an and statement. That's a compound inequality. Whenever you're solving a greater than inequality, you're guaranteed to get an or statement. Another compound inequality. So how do you set this up? So let's say, for example, we have the absolute value of some stuff is less than a number a, where a is positive, obviously. The way that you set this up, considering that it's an and statement, is going to be negative a is going to be less than x, which is less than positive a. So this is how you get rid of the absolute value inequality, the absolute value sign, and you solve just a regular old inequality. So you take whatever's over on the right hand side, you make it negative, bring it over, and write a compound inequality. Because that makes sense. It's an and statement. So I'm between two values. I'm between the positive and the negative value. That makes sense. How do you solve it for an or statement? Well, in this case, if I have the absolute value of x is greater than a, I set up two distinct inequalities. I say, well, that means that x has to be greater than a, or x has to be less than the negative of a. So this is saying I'm either way past a on the right, or I'm way past a on the left. So we set up two distinct inequalities for solving greater than inequalities. The number one mistake is setting up the inequality wrong when you first start. Box number 6 is an example. Take a look at it. I have the absolute value of 2x plus 5 is greater than or equal to 4. So because I am dealing with a greater than or equal sign, I know that I'm going to have two distinct inequalities. So the way I would set it up is, well, I know that 2x plus 5 has to be greater than or equal to 4, or simultaneously, 2x plus 5 has to be less than or equal to negative 4. So this is how we set it. Because I have an or statement, I know I'm going to have two distinct inequalities. Alright, now we solve them. Well, I would subtract 5 over here, I would subtract 5 over here. So I would get 2x is now greater than or equal to 4 minus 5, of course, is negative 1. I would divide by 2, and I would get x is now greater than or equal to negative 1/2. Or on this side, I would subtract 5 over here, subtract 5, and I would get 2x is now less than or equal to negative 9. And then I would, of course, divide by 2 on both sides. So I would get x is less than or equal to negative 4.5. So if I was going to graph this on the number line, here's what it would look like. Here's my number line. You got to give me 0. You got to give me, here's negative 1/2. And then here's negative 4.5. So it says that it's greater than or equal to negative 1/2. So I'm going to circle above negative 1/2. I'm going to color it in, and I want everything that's to the right. This one says x is less than or equal to negative 4.5. So I'd color Above 4.5, close the dot and go to the left. So this is a compound inequality that says either x is greater than or equal to negative 1/2 or it's less than or equal to negative 4.5. Any number in the shaded interval will make the original inequality statement true. Box number 7 is another example. It says the absolute value of 2x plus 9 is less than or equal to 13. So because I have a less than sign, I know the proper way to set up this absolute value inequality is as follows. Negative 13 is less than or equal to 2x plus 9, which is less than or equal to positive 13. So I am sandwiched between these two values. Now I just solve for the value of x. So I would subtract 9 from all three locations. Okay, as such. On the left-hand side, I would get negative 13 minus 9, that's negative 22, less than or equal to 2x, less than or equal to 13, take away 9 is worth 4. Now, I would divide everything by 2 in all three spots, the left, the middle, and the right, and I would get this statement here. Negative 11 is less than or equal to x, which is less than or equal to 2. Notice it's a compound inequality and it's an AND statement. So I'd graph it. It says like this. Give me 0, give me negative 11, which is to the left of 0, and give me 2. Above 11, negative 11, above 2, and we would color in both of them because it's less than or equal to, and we want all the numbers that are in between. So any number on the number line that is between these two numbers will make the original inequality true. Box number 8 is a U-try. Go ahead and solve the absolute value inequality 2x minus 1 is less than or equal to 9. Hopefully you got the right answer. If not, here's how you do it. Because we're dealing with a less than or equal to sign, I know I'm going to have an AND statement. The correct way to set up an AND statement is as follows. Negative 9 is less than or equal to 2x minus 1, less than or equal to 9. And then we just solve and isolate for x. So I'd add 1 to both sides. Negative 9 and 1 make negative 8. Less than, this is worth 2x now, less than or equal to 10. Divide both sides by 2. Or all sides I should say, rather, by 2, and you get negative 4 is less than or equal to x, which is less than or equal to 5. On the number line, I know you can't do it when you enter it, but this is what it would look like. Negative 4, 0, and a 5, close dots, everything in between.